Hey everybody, welcome back to the channel. I'm Satoshi Sean. Today I'm doing an interview with Stephen Poo from Taraxa. He is the founder. There's not a lot out there on the project, but you've been around for a while, so I wanted to go over it and kind of get some information from him. It's pretty interesting what you're doing. I do have a lot of questions on what you're doing because you're using it's different than kind of the usual blockchain project.
Yes.
But Stephen, if you just tell us a little about you and how you got into blockchain and what your background is.
Yeah, that'd be great. First of all, it's really great to be on your show. I love your podcast. So, yeah, a little bit about myself. So I had somewhat of an interesting background. I was trained as an electrical engineer, but hadn't really done any sort of hardware engineering. I primarily did launched a few startups in IoT as well as mobile health. And then was also in strategy consulting. So my last job was an associate partner with Monitor Deloitte, heading up their digital strategy division in Asia. And so what got me into blockchain is actually a pretty interesting story. I had actually first heard about Bitcoin pretty early on, back in 2013, from one of my classmates at Stanford, Bobby Lee, who started BTCC, one of the first large-scale exchanges in the world. But at the time, I didn't quite get it, right? It was pretty early, didn't quite get it. What really got me thinking about blockchain was is this sort of a convergence of the two sides of my career. One side is actually launching startups. The other side is actually working with these very large Fortune 100 companies. And what really got me thinking is that, as organizations got bigger and as projects became more complex, everything just slowed down and innovation just starts going down like crazy. And that is largely because there was just a lot of coordination costs, right? People didn't really have a way to very quickly respond to market conditions or market changes, because they need to constantly figure out how do they trust the information or validate the information that was coming, right? So that was really a big problem. When you're small, you're able to move very quickly, take a lot of risks. The amount of information you're getting is not that much. But when you get bigger and bigger and bigger, and a project gets bigger, then that becomes a lot more complex. So that was something that really got me. And I was thinking, well, is there a way for us to really, make a lot of this sort of information, business information, process information, operational information? How do I make these sort of very informal transactional information trusted, right? If we can make them more trustworthy independently of where it's coming from, then we can actually cut down a ton of this coordination costs and actually help, larger and more complex projects and organizations work much better. So that was what was really behind the impetus, because it just from my perspective, humans don't scale. Like, we don't scale very well. I mean, as soon as something gets bigger and more complex, we just slow the way down, and everything is on a fixed road to decline, like guaranteed decline. So that's what got me really, really interested in blockchain, because it was the first technology that really helped to establish this idea of decentralized trust. So you didn't really have to know where the information was coming from. Almost like you didn't have to have pre-established understanding of who the other party is without any guarantees from a third party or anything like that to be able to actually trust the information that's being committed. So that was what really got me interested, because this is the first technology of its kind, really, that's able to do that. Yeah.
You said as these projects get bigger and more complex, but that's the thing about Taraxa. You're not really focusing on the complex so much as the informal transactions, which that's the bulk of transactions. It's most transactions are classified as informal. Can you go over a little bit about what the difference is?
Yeah, sure. We think about informal transactions. They're basically like, they're like everyday coordinations, right? If the transactions are happening between people, right? So for example, like if you and I decide to have a meeting today, we just, we tweet up, we text each other and say, hey, let's have a meeting 2 p.m. today. And that's it. It's very informal, right? We don't whip out a contract that says, hey, let's sign here. We're going to show up at this time. If we don't show up, this is the penalty. Like, nobody does that, right? So the vast majority of transactions that happen between people, coordination between people. It's very, very informal. What's really happening right now is that, this has always been the case, right? The vast majority of transactional information agreements has always been very informal, very unstructured, and generally not very well captured. But what has been really happening in the past 10 years or so is that the world has gotten so much faster. Everything needs to go so much faster and faster, better, and cheaper that, reliance on this type of informal transactions has really started to create problems, right? So in industries like construction, industries like supply chain, industries like marine maintenance, or actually on the machine side, we're seeing asset leasing or IoT edge security. What we're seeing is that these type of uncaptured, unstructured, unverifiable informal information is causing a lot of confusion, is adding a lot of risk and cost. So here's a very, very quick example, right? So a quick example between people is sort of, imagine that you're doing some home repairs with a contractor, right? And of course, you sign a legal contract with the contractor at the beginning, but in the middle, there's like 100 little things that gets changed, right? You text the guys like about 100 little things, and then maybe one day you're like, hey, I thought we talked about painting the windowsill like beige, not gray, and the guy was like, did we talk about that? I don't remember. It's like, well, here's the text. Oh man, I deleted my text. I didn't really pay attention. Well, you know what? It's going to cost you another day. You want to do it? I mean, no, it shouldn't cost. We talked about this. I don't remember that. And it gets complicated, right? Is it a big deal? Not a huge deal, because if it were a huge deal, then you would have signed a contract for it. But it's sort of like death by 1,000 pricks, right? It's like, it's this stuff when it happens at a high enough frequency, it really adds a lot of risk and adds a lot of cost into your operations. And that was just an example of you like doing some home repair with one contractor. I mean, you think about a construction site with 100 contractors, right? And they're coming in and out all the time, very transient setups. And you get hundreds of these change orders every single day. People talking about time, material, blueprint changes, all kinds of changes. And this happens just very, very frequent. And it can cause a lot of problems. We're also seeing, for example, I mean, not just that the stakeholders themselves, the contractors themselves, or the prime contractor developers themselves actually running these problems. It's also creating problems for the financial institutions that are backing them, right? So imagine you're a bank and you're giving out a loan to a subcontractor who's on a project, and you're giving them a loan of 100,000 because they're going to get paid like 120,000 or something. And because of a very small beef, right? Like that's sort of like a $500 or $1,000 dispute around some whatever small issue, that payment could be held up, right, by the developer. And suddenly like a $500 or $1,000 tiny little dispute puts a $100,000 loan in jeopardy, right? So these financial players, the banks and the factoring companies are also becoming very cognizant of the risk that's involved. So what you're seeing is that these little things, right, they're very, very small individually. They really have this systematic and cascading effects and amplifies risk and cost throughout the entire sort of project at large, and also the financial ecosystem that supports these types of projects. So, I mean, everyone you talk to, right, in these fields, if you talk to people in supply chain, construction, in like marine maintenance, in all these real world fields, they'll all tell you, I mean, it's a major, major problem. Yeah. So these informal transactions, they've always existed, but maybe 40 years ago, it wasn't a huge problem because things didn't move at fast enough pace for them to become problems. But today, everything just needs to happen right now. It should have happened yesterday. It needed to be 30% cheaper. So a lot of pressure, right? Exacerbating exacerbating this problem. Yeah.
So it can really bottleneck and kind of really slow things down.
Yeah.
Okay. Now you use a DAG.
Yeah.
And a different. Can you go over how your blockchain works and the delay and the random, all that whole thing?
Sure. Yeah. So before I answer that question, I just want to preface it by saying, like, Taraxa builds a full stack solution, right? So not only do we build the application platforms on top, marinate between people and people, informal agreements. Helio is securing machine state integrity, but we also built the layer 1 protocol underneath it because it's purpose built to actually serve these application platforms. Now, what actually makes it very, very interesting is that we built this from scratch, and we were targeting, we're trying to maximize the amount of concurrency that can actually happen in this blockchain network, right? So the first thing that we did was that we took the look at the single chain topology that's very common you see in Bitcoin, Ethereum. And single chains actually have an inherent trade-off between security and throughput, right? If you actually increase throughput, you necessarily sacrifice security. In order to make up that security sacrifice, you actually need to slow it down. So you get this no-win scenario, right? That's why I think the only real way to scale up a single chain topology is through sharding, which we see a lot of other projects do. So we employ this thing called a block DAG, which effectively allows you to scale up throughput, drastically scale up throughput without any sacrifice to security. So this is actually a very, very interesting topology that we've actually proposed. The second thing that we wanted to do was that we wanted to say, hey, we want to be able to actually drastically increase the throughput even more. And the way we do that is we're adding true finality, right, into the block DAG. One of the interesting things that I think very few people talk about is that one of the bottlenecks to something like an Ethereum blockchain is because there is a risk of reorganization in the chain, right? We call them state reversions. Like, sometimes it could happen that, whoops, I built on the wrong block, and now I need to build on a different block, right? So because they have that risk, every single read and writes needs to go through the Merkle tree, right? The Merkle tree database. And that slows everything down. It's a huge bottleneck. So what we did is that we added true finality. We have an asynchronous PBFT process that says this portion of the block DAG has now been absolutely finalized. And so there's zero risk of any sort of reorganization, reordering. And so what we can do is that we can actually just, with our reads and writes during execution, we can actually hit the database directly and actually write into the Merkle tree in parallel. So that gave us a huge performance boost in the execution layer. So it's something that it's not the most sexy thing, I guess, but it's really a very, very large performance boost. The other thing that we wanted to focus on was, how do we move away from proof of work, right? I think proof of work is sort of, it's very elegant, right? It provides this very simple algorithm that provides a random fair delay, right? Which is exactly what you want when you're talking about, who gets to propose the next block. But because it can be parallelized, right? Like you can set up 1,000 machines to keep guessing this thing. You run into this arms race inside the system in which people keep ratcheting up the amount of hashing power they put into the system and consume more and more energy. We don't need, maybe I think arguments could be made that you can have 1 or 2 chains like that, right? I think BTC like that, fine. But having 10 chains like that doesn't make sense. They consume, that unnecessarily consumes the world's energy. So in order to replicate that fair random delay, we're using a combination of verifiable delay function as well as verifiable random function. The interesting thing about verifiable delay function is that it actually is sequential. It cannot be parallelized like proof of work, right? So somebody can, it doesn't matter how many computers you have, because the result of the next iteration depends on the previous iteration. So you have to have done it first in order to get to the next result. So it's sequential. So you can't deploy 10,000 machines on it. You have to just use one really fast machine on it. So, and then that's much more easily controlled. You don't end up with as big of a, you don't nearly end up with like a big of an arms race then. And the verifiable random function just adds a degree of randomness, right? So we have a random delay, right? That's fair. That replicates what proof of work does without, all the parallelized energy drain. So we have some very interesting innovations actually built into the layer 1, and all of it is really, we're building all of this with an eye, really specifically looking at, how can we make this audit logging or data anchoring use case that we're enabling on the application layer much, much, much better. That's why, the stuff we're focused on is business logic execution, not just simple coin transfers. That's why we put a lot of time into figuring out how can we improve the actual VM execution layer, right? Whereas I think a lot of other projects, because they're pure financial driven, they're really just only focused on coins, right? Like coin this, coin that. But we're looking at, business transactions. We're also looking at, the specific use case of audit logging these are what we call stateless transactions, in which they don't really depend on previous transactions and they don't impact any subsequent transactions. So we're actually able to do a lot of what we call speculative concurrency. So even before things are finalized, we can actually start executing these transactions and actually committing them into the blockchain state, because they're stateless, right? So that actually additionally increase the throughput. So there are a lot of these little features that we're adding into our layer 1 that are specifically targeting this use case. So that's why we call it a purpose-built layer 1 blockchain. And like I said, right? I mean, I think every piece of technology is really meant to serve a purpose, right? You can't just build like a generic technology, throw it out there and say, oh, build it and they will come, right? That hasn't really worked out very well for most of the layer 1 blockchain that are sort of meant to be generic platforms. So we're being very cognizant about that, and we're going to drive adoption into our application platforms, which we build ourselves, and then in turn drive adoption of our layer 1 protocol.
Okay, so you're moving away from the proof of work. How exactly is the proof of stake going to work, as far as are you going to have master nodes? What's the staking rewards, all that kind of stuff?
Yeah, a great question. So I think the proof of stake sort of economic mechanism, the market has more or less sort of converged on a sort of framework I think most people are familiar with, right? So first of all, people there's a delegated proof of stake, right? So you can be a coin holder or you can be a node operator, and then you can stake into a node operator and you guys decide what you want to split out the profits, right? So the staking themselves gives you the privilege of producing blocks, right? So if you stake a certain amount, a minimum amount, that gives you the ability to propose blocks and to participate in the PBFT voting. So that's sort of in a nutshell. That's what that really gives you. In terms of the rewards, for staking, we have this incentive system set up in which we try to target a specific staking rate, and we set a target rate to be 67% of the network's total token supply. And the reason why I said that is it's really a security threshold for most of these types of systems. You need sort of 33% of the network, over a little bit over 33% to actually attack it, to mount a very sophisticated attack. So we want to make sure that most of that is locked up. Now, the reward is that at the peak, if we hit the target 67% lockup rate, you get a 20% annualized yield. And that comes in the form of inflated block rewards, right? That comes from these new blocks that are being generated in the DAG. So that's pretty much how that works. And then there's a ramp up and ramp down before and after the 67%. So this is all in our documentation, docs.taraxa.io. You guys can come and check it out. Everyone can check it out in the economic model section. These are preliminary models. I'm sure that there will be additional discussions once we launch the mainnet with node operators, and we're obviously going to be listening very closely to the community's thoughts on what the right adjustments are being made to these economic conditions are. We did a lot of research looking at other protocols, like people like Polkadot, Cosmos, some of these larger ecosystems, and who have put a lot of thought into how to structure their economic incentives with their staking. So, but of course, I think in the end, it's the community that needs to decide that, not us. Yeah.
You have a pretty good sized community, which I'll put links in the description for the website, and you can find all their social media platforms from there. Can you go over the anchors and the cross-chain bridges?
Oh, the crosschain bridges. Well, sorry, the first one you said anchors?
Yeah.
Okay. Are you talking about data anchoring? Is that what you're talking about? Yeah. Or okay. Yeah. So the data anchoring part of it is an application specific term that we're talking about. It's really a way to build up audit trails, right, for our application. And this gets to the idea of sort of, well, how does blockchain really help you to establish trust, right? Because it's sort of like, blockchain is a piece of technology. The technology or computers, they don't really know what's true or not, right? I mean, I can enter something to a form say, I have $10,000. Like the computer doesn't know whether that's true. It has no way of telling whether or not that's true. So why are we using blockchain to sort of add trust, right, to these informal transactions? Well, it's really sort of figuring out, well, what can blockchain technology guarantee when it comes to data that's not native to the blockchain, right? Data that's native to the blockchain, things like just coins, for example, like if we're sending you a coin, then you have 100% guarantee on the truthfulness of actually that information because it's native to the chain. It's able to fully verify it on its own. But when you're dealing with information that's off-chain, which is vast majority of the world's information is off-chain, how do you tell, right? Well, you can't tell the truthfulness, but you can tell the source of the information, right? Provenance, because of the digital signatures, the cryptographic signatures. The other thing that you can also tell is the immutability, right? So once the data has been generated, it hasn't been tampered with, right? So if you have, provenance as well as immutability, and you combine those two, and you start anchoring, hashes of these agreements and of these informal transactions into the blockchain, then what you can do is that you can actually start holding entities accountable, right? So it doesn't know whether or not the information is true, but it knows who wrote the information and when. So it's a perfect record of who said what when, right? So by holding the committing entity accountable, often you're creating a huge disincentive for people to commit fraud, right? Because I know what happened, right? You can't get out of it. You can't say like, oh, that never happened to us, blah, blah, blah. I never said that. Is that what we really said? No, you can't back out of it. This is exactly what you said. This is exactly what we agreed to, and in that order, right? So by holding entities accountable and guaranteeing the source, the provenance, as well as the immunity of the information, you can actually guarantee a lot about the trustworthiness of that information. So that's what we call data anchoring. We call it anchoring because because it's really, it's not uploading the raw data, right? Uploading the raw data is just bad for so many reasons. First of all, it's not private, right? No person or business or organization will want all their data just like transparently uploaded into the blockchain. That's not a good idea, right? Second of all, it's very wasteful, right? Blockchain decentralized systems are much slower. So we're just anchoring the hashes of these things and the signatures, which to an external observer, they're just sort of, they're just random strings. So the privacy is secured and the data footprint is much smaller. So you have much better efficiency. So that's why we call it anchoring. And the data anchoring idea is sort of through the provenance and the immutability that guarantees accountability. That's why you're able to trust that information much more, because it's creating these incentives that, that really disincentivizes people from lying. The idea of this sort of the cross-chain bridge, right? The cross-chain bridge is something that we've been thinking about actually from two perspectives. The first perspective we're thinking about it from is an application perspective, which is that eventually what we're really thinking about, what really makes the blockchain network or any kind of network valuable is how much network effect do you have, right? So, I mean, just let's look at Ethereum. Like, why is Ethereum so awesome? Well, because it has found the perfect use case. It has found its use case niche and it's found its product market fit in financial financial assets and financial instruments, right? So there's so much money right now locked into Ethereum, so much DeFi going on, NFTs. It's really the financial platform, right? When you're thinking about blockchain. Well, okay, so that's great. And the cost of leaving that ecosystem is very high because that's where everyone else is, right? You want to trade with them, you want to interact with other projects, then you got to be on Ethereum, right? So what is that, what is that thing for Taraxa? Well, the network effect for Taraxa we eventually want to actually create is this idea of reputation, right? You have this decentralized reputation. No, so to give you an idea about that, it's actually very interesting. So if you go to a bank, for example, if you go to a bank and you say, hey, I want to take out a loan. Okay, right. So why should I give you a loan? What do you have in terms of collateral? Well, I work with these other big companies and we have customers. We have established relationships. I have these contracts with them, right? And the bank were like, yeah, that's fine. It's a piece of paper, but like, how do I know you're not making this up, right? Like, prove to me you're not making this up. Right. And a lot of times it's very hard to prove. Right? And this is why our small businesses across the world have a very hard time getting access to capital because it's difficult. There's so much fraud going on and it's difficult for them to prove that they're in any kind of real interaction with these other businesses. So what we're doing here is that, like we said, over 80% of the world's transactional information agreements are actually informal. But here, what we're doing is that we're capturing a good portion of that and we're anchoring them onto the blockchain. So what you can think about later on is that you can use that as a means to prove your established relationship with these other business entities, right? I can go up there and say, hey, you should trust me because I'm doing business with Sean. Well, how do you know you're doing business with Sean? Well, look, I have all these transactions with Sean on the blockchain, and then you can reveal, say, hey, I am going to reveal that these signatures belong to me, right? I can prove to you that these signatures belong to me. So I can say, yeah, look, I have all these interactions with Sean. Yeah, maybe I can pay him off for like a one-time transaction, but I've been working with him consistently for the past year. That's difficult to fake, right? All that history, right? So yeah, so that's a way to actually prove that you and I have a working relationship. And over time, I can prove that I have lots of working relationships with lots of other people. So that's a way to actually prove reputation and credit worthiness. That's what makes it valuable, right? So the reason why we say, well, coming to your question, what does this have to do with bridge to Ethereum? Well, if Ethereum is the financial hub, right, then that credit worthiness is going to be a very interesting input into a lot of financial instruments, guaranteed, right? I mean, I think right now, I think the loans and the financial instrumentation are limited to the crypto world, right? People are sort of staying inside the crypto world with their borrowing, their lending, all this financial stuff. But I think obviously the biggest market is not in crypto, but in the real world, right? So can we get some of that information from the real world to actually provide reputation or provide data input into these instruments that are being made on the crypto world? So that's one, I think, very good reason why we want to build that bridge. The second reason why we want to build that bridge is actually for purely security reasons, because proof of stake networks are vulnerable to this thing called long range attacks, which involves people buying up old keys. But I won't go into the details. But the idea is that you roll back history so long enough, people can conceivably create like a parallel reality that eventually dominates the existing reality, right? So it is a risk, right? So one of the ways that we can think about that is, well, actually a way to really mitigate that risk is to anchor your snapshots of your state, for example, into other chains, right? For example, you can anchor into the Bitcoin chain, you can anchor into the Ethereum chain, and then that becomes a lot harder to attack, because in addition to having to compromise our network, you have to go and compromise these two other networks, which collectively becomes almost mission impossible and not profitable to do anyway. So for a security reason, I think it would be very interesting to start building these bridges to anchor our networks like states, right, into these other chains.
That is really cool. Well, Stephen, that's about all I had. Questions on anything? You want to go over your roadmap or anything coming up?
Yeah, sure. So for the past 2+ years or so, what we've been effectively doing is that we've been building a lot of our technologies, and we have been building our application platforms and actually doing a lot of the grunt work into really validating that these ideas, actually very big ideas, actually have traction in the real world, right? For us, 2021, we are looking at basically two large goals. One large goal is we need to launch our mainnet, right? And of course, in order to launch our mainnet, not only does the technology have to be ready, our tokens also need to be in circulation. So please on the lookout for any kind of liquidity event. We'll be making those announcements soon from the foundation side, of course. The other thing that we're going to be very focused on is driving adoption into our application platforms. So we're already talking to, we have been working with a lot of very, very great partners, right? So also please be on the lookout for these announcements that we're going to be making in the near future. We have been working with one of the largest automakers in the world for peer-to-peer car sharing, as well as a second car sales. We've been working with this very large asset leasing company based out of Japan. We've been working with a very large global company that works in automotive parts quality control. we are starting, to talk about a partnership with one of the largest shipbuilders in the world for marine maintenance to help them add clarity and transparency into their operations. So there's a lot of very interesting use cases that we're deploying, and we're going to look to drive these use cases, growing these use cases, and actually driving adoption for our platform, for our application platforms, and in turn driving adoption for the Taraxa network. So yeah, it'd be great. We'd love to come check us out, come to our website, come to our Telegram channel, and come check out our Twitter. It's all on our website, taraxa.io. So come check us out.
And is like to have you back on later on after you get the mainnet going and all. It was good hanging out with you. It's good hanging out with all y'all. Remember to hit the like button, crush it, subscribe if you haven't, hit the bell for notifications. I will see you guys in the next video. Steven, thanks for hanging out.
Yeah, thank you very much. Bye.